Hi guys, I just want to do a little review with you on proportional relationships before I give you, or before I have you complete an assignment. This is review for SBAC. At the very beginning of the year, this is actually the very first page after the learning targets, we put in a proportional relationships foldable. And so I'm just going to run through what that says. If you don't have this, you're welcome to pause the video and make it as I go through it, but that's kind of up to you. So there are 4 ways that you can recognize a proportional relationship: in a graph, in a table, in an equation, or in a situation. In a graph, a proportional relationship is going to be a straight line, and the slope stays the same. We wrote that here as change in y per change in x, rise and run, like that change stays the same. We hadn't learned the word slope at that point. And it passes through the origin, which is 0, 0. So here's an example of a proportional relationship, and the slope, which here I called k because we hadn't been using the letter m at that point for it, is 1/2. So for every increase of 1 in the y direction, there's an increase of 2 in the x direction. And then here's an example of a proportional relationship that has a negative slope. In a table, there's a constant rate of change. You can see that there's something being added or subtracted constantly throughout. And it includes 0, 0, or I did make sure to say it could include 0, 0. Like this example doesn't actually have 0, 0 in it, but if you work backwards, you would see take away 5 here, take away 2 here, you would get 0, 0 in the table. In an equation, it looks sort of like a linear function, which now we know about, but at the time we did not know about linear functions, except there's no b, there's no y-intercept. So it's all going to be y equals something times x, because a proportional relationship has to pass through the origin 0, 0. So the y-intercept of a proportional relationship is always 0. That's why it doesn't show up here. It would be like negative 2x plus 0, 1/4 x plus 0. That's this nothing added or subtracted part. That means that there's no b in the equation. There's no y-intercept. So we called this the unit rate, or the constant of proportionality. This number that later we learned was also called slope. It goes by many different names. And we talked about how the greater the slope, the steeper the line. So like this one that's 3/2 x is going to be a steeper line than this one that is 1/4 x, because this thing is increasing at a faster rate. Then here's a situation. There's a constant rate of change, and there's no initial fee that would be considered your y-intercept in a linear function. So just straight $80 per day, $5.50 per hour. When you put gas in your gas tank, you pay $2.72 per gallon. That's a proportional relationship as well. So proportional relationships are special kinds of linear functions. We also created this Venn diagram describing the two, or kind of comparing the two. So the big thing is that the proportional relationships must go through 0, 0, and linear relationships can. That's what and if it does go through 0, 0, then it's a special kind of linear relationship called a proportional one. So a graph can be both proportional and linear. If it's proportional, it's also linear. But it can be linear and not be proportional. Kind of like how a square is always a rectangle, a proportional relationship is always a linear relationship too. But a rectangle is not always a square, just like a linear relationship is not always going to be a proportional relationship. I hope that geometry reference didn't throw everybody off. But okay, so that's a review, and hopefully you that kind of struck some memories loose, and you'll be able to do the worksheet that I'm going to give you.